All right, welcome to the hypothesis testing video for A level. We're going to go through everything: hypothesis testing, one tail, two tail, the upper side, two tail, both sides, and we're going to look at how you do it for normal, binomial, and PMCC, because they're the three things which you could get asked to hypothesis test. And I mean, I could try explain everything at once to begin with, and then show you examples. But I'm sort of kind of going to do both. So I'm going to give you a quick explanation. There's 4 points here which I think are important, and I want you to know it in that order. So I'm going to tell you a little bit, but then as we go through the examples, you'll kind of pick up more understanding. So it's don't overthink, oh, this doesn't fully make sense. Watch as many examples as you need until it makes sense. Now I'm going to go over it first. When I go through the examples, I'm going to first do the normal, then the binomial, and the PMCC, which is so piss easy. Once you understand these two, it's ridiculous because there's so little work involved here. But let's get into this, okay? So hypothesis testing is, first let's kind of bring up like a question. And I'm just going to start off with picking a normal distribution one. Once you get the hang, it's all the same. Okay, so have a read of that, okay? So this is your typical type of question, okay? The time X minutes is taken by athletes in a running club to complete a certain run following a normal distribution. So let me actually move that a little bit as well. You've seen the second Y. Okay, so here's what it's saying, okay? If we just read this question, so this taken by athletes in a running club to complete a certain run following a normal distribution, where the mu is 12, standard deviation, well, variance is 4. Coach increases the thing, so there's scenarios, okay? So they think this scenario, he's increased the training sessions, he's taken a sample of 20, and since the increase, he's noticed a mean of 11.12 minutes. And then you're saying, assume the variance has remained unchanged, blah, blah. Test at the 5% level, that's your significance level, and suggest whether there's evidence the mean time has decreased. So that's kind of hinting towards, you know, what the test should be. So whenever you're doing any of these hypothesis test questions, there's 4 things you want to always keep in mind, okay? Number 1 is you want to be clear on the distribution which you're testing. Now, I'll just say that for a second. So for the normal, by the way, it's always going to be the sample means, okay? It's the sample means. So this thing right here doesn't actually, I mean, it's going to help you find the sample means, but I just want to make that clear, okay? So for the binomial, it's going to be pretty straightforward. It's whatever's in there, we'll see that as a question. It's going to be something like, you know, binomial, I don't know, 17, 0.3, you know, your N and P. And for your PMCC, well, that one's even easier. So let's not look at that right now, okay? That's where you just kind of pick values from a table. All right, so then there's going to be a significance level in the question. So you can see it says 5% here. You just want to make a note of that. And then you want to decide if your thing's one tail or two tail. The reason this is important, if it's a one tail test, you really are going to basically be looking at the 5% level. But if it's a two tail test, you're going to be splitting that 5% into 2.5 and 2.5. So, and you're going to be testing one side. So really, when it's a two-tail test, if they give you a 5%, if they say test at 5% level, essentially you're testing at 2.5. If they say 10%, you're testing at 5. If they say 1%, you're testing at 0.5%. Again, don't worry if this doesn't make sense like fully yet. With questions, it's going to make more and more sense. I'm going to go over every possible question. And finally, then once you kind of set up your test, we need to be clear on what is the value for which we're testing for. Okay, in this one, it's going to be, it's always the observed value. They saw that it was 11.2 minutes was what came out. That's what we're going to test. But okay, now let's actually look at this. Okay, so now let's kind of take you through a question like that, okay? And I'm just going to give you a bit of an overview. Okay, the distribution to test here, bear with me. In this question, because it's a normal, the mistake which people make is they'll try to test on that normal distribution. It's not. You're testing the sample means on the normal. And really, it's only with the normal hypothesis testing which you're ever going to get that trick thrown at you. So, you know, the distribution you're testing here is going to be 12, and it's going to be 4 over 20. That's your variance for your sample mean, okay? Yeah. Significance level, they'll say that in the question, it's a 5% one, okay? So it's 5%, or you can think of that as 0.05. Okay, now here's the important thing. You also need to know one tail or two tail, and that comes from your H0 and H1. So in normal distribution questions, you know, you're always going to be testing the mu, basically. So in this thing, you're always testing that. They're saying, oh, you think the mu is 12. You've got to have a value to test against. And to decide whether it's a one tail or two tail, you've got to look at the wording. Okay, you have to look at the wording. And in this one, can you see? Show whether evidence the mean time has decreased. So they're not worried about, oh, has this gone up? They're like saying, okay, is it now less than 12? Because the guy's kind of brought in a few training sessions, like, is there any use? Imagine if you're training for like a run and you're doing 12 minutes. If you increase the number of sessions, you don't really think you're going to get slower. The chances you're going to get faster. But they also could have been, you know, someone could, if they had said the mean time has changed, then you would be going towards not equal to 12. But this is a one tail. Yeah, okay. So now just basically, before I go to one tail, I mean, this is one tail, okay, one tail. So let me just quickly kind of understand here. So here's the deal which we have so far. So here's your distribution, okay? Your X bar normally distributed at 12. And you got standard deviation of whatever. You know, in a way, it's almost more useful to think of it like this. Wish I was going to be testing with that, but hopefully that makes sense. Okay, here's the deal, okay? The middle point, the highest place where it peaks. Now, this is going to be important, especially with two-tailed tests. You need to understand where it peaks, especially on binomial. But basically, it peaks at the mean for the normal. Okay, so it's 12 here. Now, here's what it is. We're basically seeing, does it fall into the critical region on the edges? And these are the most extreme values, okay? So for a one-tailed test where you're testing, oh, has it fallen, has the mean decreased? We're saying, oh, has it fell into this extreme 5% here? If it's in there, we're going to say, okay, H0 is too crazy. This is too unlikely that H0 happened from what we've seen. We're going to say that this is rubbish and we're going to tick that. Does that make sense? Yeah? And, you know, blah, blah. And if it was we're testing higher, we'd be looking on the other side. And again, don't worry too much if some of this isn't making sense. With questions, it'll make more and more sense as well. Just right now, just listen and get a feel. You're testing 5% here. That would be if you're doing mu is greater than 12. And I'm going to tell you in a second what that means of what we're testing here, yeah? Okay, and then finally, a two-tailed test. Now, this would be when you've got like mu is not equal to 12. So what we'd be doing here is, it's basically we're testing, we're like saying, oh, we just don't think it's 12. We're not making a specific reasoning of we think it's increased or decreased. We're like, it's just not 12. So what we're saying is, does it fall into the extremes on either side? We don't care which one, but if this is so extreme it falls on either side, we're gonna say that this is rubbish. Otherwise, we're gonna say it's fine. Now, here's the deal. When you're dealing with 5%, because you're splitting this on both sides, you're not testing at 5% on each side, because that will be a 10% significance level in total. You have to half this, and now you're testing at 2.5% either side. And you're only going to be testing on one side anyway, but two-tail essentially means slash the significance level in half. That's literally the best way to think about it, slash it in half. But anyway, okay. So right now, here's the deal. Bear with me. Okay. So there's your distribution. You figured out it's a one tail. So you're not going like that, which means your entire significance level is here. You're testing. You're looking if what you've seen falls into this 5% of extra craziness. This is too mad. All right. And the best way. Yeah, okay, just keep that in mind. Okay, and then you need to understand what value you're testing. Because obviously we're seeing what falls into this crazy level. Well, in the question, can you see in your sample of 20, the sample of 20 in normal distribution is purely to get this value here. It doesn't really mean much else. But it's you're testing 1.12. So can you see, obviously you know that 1.12 is on this side of 12. So 11.2 is on this side of 12. But here's all you're deciding. There's two scenarios here. You're basically seeing, does 11.2 land obviously on the left side, but not quite in that mad region? In that sense, you would just kind of say that, no, this is good. Yeah, there's nothing crazy here. We can accept that. Or does it fall in this mental region, which is just so goddamn unlikely? That's what we're testing. And the way we're going to test that is there's two kind of scenarios, okay? So let's have a look at the situation where, imagine your 11.2 was here. And imagine if you always find the probability less than if you're looking on that side. If it was like 13.8 we were testing, we would obviously find the probability of it being greater than 13.8. But in this instance, because we're looking on the left side, we're going to be finding out the probability of less than 11.2. Now, here's the deal. If it equals, say, like 0.07, okay, which is bigger than that, but let me give you in context what that means, yeah? And let me actually draw this again so it's a bit bigger so I can say that. So if that's 12 and you've kind of got your 11.2 and you figured out that this is 0.07, well, can you see your critical region would be the cutoff where it's 5%. So by figuring, and 0.05. So by figuring that out, by just looking at what's the probability below it, you figure out that 11.2 is not in the critical region because it's still got this extra bit there, so it's got to be on the right hand side of the critical region. It's not in the critical region. However, if you had figured out it's like 0.03, the situation changes. Because remember, you're trying to figure out, does it fall into this weird area here? So you got the situation, here's 12, you figured out that 11.2 is this thing here is 0.03. Well, think about that. If you're in the bottom 3%, which means you're inside the initial, this is too crazy, 5%. That's how we're going to do it. Okay, and that's how it's going to work for normal, for binomial, for PMCC. Okay, and it actually works the same for if you're doing, like, if you're testing the one tail on the higher side. So if you're testing, hey, is it gone bigger than 12? And we're going to look at an example like that as well, and also for when you're testing two-tailed ones as well. All right. So the best way for this is, let's run through a full question, and I'm going to show you how to lay it out as well. So we'll do a few normal distributions. Feel free to skip wherever you need to skip, but I recommend just make sure when I go through the examples, I would recommend you follow me through for the first one or two examples on the normal, one or two examples on the binomial, and one or two examples on the PMCC. PMCC is so piss, it's mental anyway. Okay, so let's have a look at this. Here's how I would personally set it up, okay? So for normal distribution, the first thing you want to do is you want to get down, let's just kind of write down. So we know it's x equal, let me pick my colors as well. Okay, so the first thing, I'm going to roughly just bring up like a little thing which we do every single time. So the first thing is I would write my distribution to test. Distribution to test. So this is my work in here as well. I'm just going to make a few notes here, okay? So I'd write my background distribution here. That's what I'm testing, but that's not my distribution test, okay? It's this thing here, 4/20, okay? That's my distribution to test. That will get you 1 mark, by the way. Here you go. Here's your 1 mark right here. Okay, number 2. Okay, it looks like this is just me going to go in colors all over the place. Number 2, as I keep going down here, number 2 will be H0 and H1. So you literally just write, okay, H0 equals mu equals 12. There's always got to be a specific value for that one, and this one is less than 12. Okay, so that's what we're testing for. Number 3, okay, this is where I just call the setup info. And this is just more for you kind of mentally, okay? So you're going to say its significance level is 0.05 and it's one tail. Okay, so if I just, and I like to, and like test, you know how I always put the value to test, yeah? Test value, I like to write that, you know, 11.12. I like to get clear on that. And visually, I'm going to make a sketch. After a bit, you probably won't need to, but I want you, as you practice this until you feel completely confident, to just do a sketch on the side. Trust me, you're doing it and making sure it lines up with what I do as I go through these questions. You should be pausing this video and like trying the question, then seeing what I did. Do it until it feels second nature, okay? So here's the kind of like, here's what I'll do. Here's my kind of distribution. I know 12 is in the middle. I am testing where 11.2 ends up. No, actually forget that. Here's another. So I'm saying I'm testing this bottom 5%, and literally all I'm testing is I'm trying to figure out where my 11.2 lands up. Is it going to be here, or is it going to be here? Does that make sense? Yeah, that's what I'm testing. I'm testing where the 11.2 lands up. Okay. So we've done that. And by the way, okay, so your second mark realistically is going to be here. You're not really going to get any, you're not going to get any marks for that, okay. So number 4 is what we're going to do is we're going to actually, we're going to do the test. Let's do the test, okay. So the way to do this test is we're going to look for the probability. Because we're on the lower side, we know that 11.2 is going to be on that. So we're going to find that we're going to find out what the probability of less than 11.2 is. And it doesn't matter if you do less than equals to on a normal distribution, because remember, this is a question they sometimes ask on a normal distribution. What is the probability of x equals 11.2? The value of anything equaling is 0, okay, but ignore that for now. But that's a little side thing. So let's test what less than 11.2 is. If it was on the if we were testing on the higher end, by the way, we'd be testing less than greater than 11.2. Okay, but we're not. So grab your calculator. Do that. I got the calculator with me as well. So remember, and I'm just gonna, for the first few times, just kind of like write exactly what you need to kind of shove in there as well. So, you know, it's going to ask for an upper value, put that as 1,000, 10,000. Remember, they always ask for a lower value first. So you actually want to do, no, what am I talking? Yeah. No, my bad. My upper is 11.2. Yeah. Lower is like, I don't know, minus a huge number, minus 1 million or something. Mu is, oh, God damn it. I hate this calculator. Okay. My mu I got as, well, it's the square root of 4 over 20. 4472136. Feel free to skip this bit. I'm just taking forever on this. You just need to see if you agree with my value. Okay, here's the value I've got. 0.0368, which I assume, let me just double check. I haven't made a stupid error on that, by the way. Forget that, I'll just check later, okay? That's what it is, okay? Now, here's what this one's saying. Let me just explain this up to you as well. What we're saying here is we found out if that's 12, if we put 11.12 here, we found out that the probability here is like 3.68%. Well, obviously, can you see that's going to fall inside? Well, I'm looking at, does it fall inside the initial 5%? Well, of course it does, because it's in the lower 3.68%, where we're like, if it's in the lowest 5%, it does, okay? So what you need to kind of say now, number 5, I'll leave it in red now, okay? Number 5, is it in the critical region? So just kind of do that like 0.0368 is less than 0.05. That's that always is talking about your significance level here, the one which you've actually picked in the question, and just say it's in the critical region. You know, and then it's finally like conclusion with context. Okay, they love context in stats. They don't just want you to say reject H0. They want more. They want you to talk about it. So, 1 second. Let me just find this in the... Okay, bear with me. Feel free to skip any of this stuff where I kind of get slow. Yeah, alright. What's the... So yeah, ignore me anyway, yeah. So you're going to say, like, reject H0, but that's not actually enough. But, oh yeah, by the way, this will get you your 3rd mark. I assume your 4th mark is somewhere here as well, you know. It's that, the fact that you've shown that it's in the critical region, and you might get like, and by the way, sometimes a 6 mark is usually for when you're doing greater than it. Oh, forget that. Okay, 4th mark is here. And then just write in context, or what was the context, you know. Yeah, sufficient evidence to suggest that the mean time taken for a run has decreased thanks to the increased number of training sessions, or something like that. Does that make sense? Okay. But can you see here, the 4 big things which I'm paying attention to is I'm being very clear on the distribution I'm trying to test, the significance level, which ties in with the 1 or 2 tail test, because I got to half it for significance level, and I'm getting very clear on the value to test. All right. Now let's kind of look at a different example where you're doing a 1 tail test on the higher side. How long is this video? Fucking hell, 20 minutes. And if you're wondering, oh, why doesn't he just pick like a big section, just do delete? I don't know. The software doesn't let me. I'm not, you know, I'm not like a dinosaur with computers or nothing. Or I like to think. Okay, let's go to another one. Let's zoom out a bit. Okay, what's a good question? Okay, we'll get to that in a second. Okay, here's a good one. So if I kind of bring this question up. This clay pigeon thing. I'm just going to do this one, okay? They're breaking it down to this, do the no tails, this side where it's a 1 tail, 2 tests. Alright, but you know what, I'll bring the whole question and then we'll have a look, okay? So here you go. Let's get very clear on these things first. Okay. Okay, so this weight in grams of the pigeons in a city. The weight of pigeons in a city is normally distributed in that. Okay, so you know in this one, it's these pigeons are normally distributed 300 with the standard deviation 45, so you're at 45 squared. But that's not our distribution to test. It's a random sample of 25. So we're going to do x bar. It's normally distributed. The one we actually care about is 300 over 45 squared over 25, which actually, if you put that in the calculator, it just becomes 9 squared, but forget that for now. Okay, the significance level. So first, let's check if it's a 1 tail or 2 tail. It goes, the council claims that the city's pigeons on average they're heavier. Okay, so this is going to be where we're going to test that the mu is greater than 300. Okay, but you want to get on that as well. So we've got a significance level of 1%. Yeah, but because this is this is a 1 tail as well, so it will stay 1%. Tick. Okay, the value to test. You know the sample of, this is the where they actually picked 25 pigeons and they saw the mean was 314. So we're going to be testing that. Okay, now let's kind of go through this as well. So number 1, test distribution. You want to write the test distribution. So I recommend writing, you know, x is So this is the pigeons, what they actually saw. But our test distribution is actually this. Okay, so that's our test distribution. Number 2, H1, H1. So H0, we believe that the mean is 300. H1, no, we believe that it may have increased. That's our null hypothesis. Third one, and by the way, we've got 1 and 2 marks already for just writing that. Okay, setup info. So what did I say here? You're right, it's a one tail. Okay, sig level is 1%, and test value. I really like to get clear on this as well. Yeah. So the test value from the question, the thing we've actually seen is that 314. Okay, so our test value is 314. Okay, yeah, fair play. So now let's test it. So by the way, let me just kind of draw a picture of what we're trying to figure out. So here you've got your little distribution, this one here. Okay, so it's this 300. We're obviously we're testing the higher side anyway. So we're looking if it falls in this top. This is 1%. Oh, why did I change the color? We're testing if it falls inside this 1%. Okay, so essentially we're saying, hey, does our 300 we're saying, does our 314 land here? Is it in the too crazy region? Or does it land here? Is it not? Now the way we do this, okay, we do this by testing what's the probability of it being greater or equal to, this is not important, you can have it or not, than 314, okay? Because we're going to have two things happen. We could either get a number which is, we get something which is bigger, or we could get something like 0.006, which is smaller than. In short, this is going to be, well, let's have a look at that, okay? So if you get 300 and you find that the probability of it being 314, you find that's 0.03, which is 3%, yeah? Well, essentially what you've done is you figured out, oh, the critical region then lays on this side, 1%. So your 314 is not in the critical region. However, on the flip side, if you found out that this is 0.006%, which is what, 0.6%, well, that means that 1% is on this side, so it is in the critical region. Hopefully that makes a bit of sense. Like I said, the way to test it is let's test greater than or equal to, doesn't matter, 314. We figured that one out. What's that going to be? Okay, so make sure you're doing normal distribution correctly. The mu on this, by the way, is 9, which is nice. Okay, so here's what I kind of found out. The probability is 0.0599. Okay, so clearly here's what's the deal. Here's what the deal actually is. Here's 300. If we look at 314, we figured out that this area is 5.99%. Well, then of course, well, the bottom 1% has to lie inside this. So 314 is not in that critical region. Does that make sense? It's out of it. So what you first just write, 0.0599 is greater than 0.01. Our significance level, so not in critical region. And this is going to get our third, maybe our fourth mark. They usually give one more for when you're doing when you're testing higher. But nowadays with calculators, they may have taken that out. It doesn't really matter. You just focus on that. And so then you can do your conclusion stuff. Accept H0. No sufficient evidence to suggest the weight of pigeons at the city centre this year is heavier. Yeah. Does that make sense? Yeah? So hopefully that does. Maybe we do one more one more one tail on the higher side, then we look at a two tail one. If you feel completely good, feel free to just skip this example. If there's any shred, even a tiny shred of doubt, you watch me, okay? Or you wait till I pick the question. You can skip this crap, obviously, like when I'm kind of rubbing out and stuff. Don't waste your time watching me in this. But you basically make sure you're correct with, you do the question basically. How's that? Okay, so here you go, I found the question. So it's question 5. So our good friend Kyle here has been studying and believes that something has happened. Test that, 1%, 5%. Whoops. The reason I had the OJ Simpson thing is I was actually going to talk about how that relates to hypothesis testing. It's like you've got to bring that evidence. Or we've shown you that, like it's in that bottom 5% without doubt. That's not a good explanation, but trust me. No, just ignore it, to be honest. Okay, let's have a look at this. The number of hours Kyle spends studying each week follows a normal distribution with mean 32 and standard deviation 5. That's the background population. Okay, he believes the mean amount of thing he spends each week has increased, so that's a one-tail test on the higher thing. That's going to help you with your H1. In a random sample of 20 weeks, well, that's going to help you find your X bar, the sample mean distribution. Okay, it's going to be 5 squared over 20, the variance over the past year. And the mean number he spent studying was recorded at 34. That's your value which you're going to be testing. Does that make sense? And it goes, use a 5% and a 1% level to test Kyle's belief. And this is actually going to be quite a, and this is going to be, we'll do both of it. So there's actually 2 tests which we're doing here, just to show you how things differ based on what tests you kind of do. Okay, so let's start by, what do we do first? Okay, we're going to write our test distribution. And by the way, this is going to be the same on the binomial and all of that. Well, binomial. Okay, so, it's nice to write there, especially when they don't give it to you on this one. So, we're dealing with 32 5 squared, but I don't know why I've done binomial. I guess it's when I'm talking about it. Okay, but the sample mean distribution, the one we care about, is actually this one here. Okay, ding, well done, you got 1 mark. 2, let's put a H0 and H1. So H0 obviously is always going to be, we're testing against this thing. So we're saying that the mean is 32. But what we're testing here, because it's a one-tail, we're looking at whether it's increased. So we're saying it's increased. Okay, so if we just kind of look at our distribution right now, we know that's 32. And we're just looking at has it increased? Okay, let's hold that for a second. So that's our thing right now. Just a setup info, by the way, here's your second mark. Setup info. Okay, it is a one-tail, which means your significance level, we're going to start with the 5%, by the way, yeah? It is actually, we are going to be testing 5%. Okay, that is the significance level which we're actually testing because it's one-tail. If it was two-tail, we're going to half it. We're going to see that in a second anyway. And finally, I like to always put down the test value, the thing I'm actually testing. He was recorded as 34. This is always a thing which it's like, we took a sample of this and this is what we saw. That's a test value. So here's the deal right now. So, we're looking, does our test value fall in this upper 5%? So once again, we're testing, hey, does it fall here? Is 34 in this kind of this is too crazy area? Or is it nicely outside and it's not significant? Okay, but that's what we're doing. Okay, so now let's test it, And the way we test it, again, test it. You test it by looking at the probability of, hey, what's the probability it's greater than 34? Because again here, if we find the probability of that and we find that it's 8%, well, what that's kind of just said is, well, that means the bottom 5%, don't know why I'm pulling out green this time, there's no reason for it. It means this is outside and that's not significant. And we do that by testing greater than. And we do greater than because we're testing on the right side here, yeah? And the extreme is on the higher end. But, you know, on the flip side, if, you know, I do 314 and I find that this is like 2.6%, you know, like a 0.026. Well, what that means is clearly that is inside the bottom 5%, you know, because that would be the 5% cutoff. So again, you know, I know I'm repeating myself, but I'd rather repeat and you get it, even though you might get kind of like bored across the whole time, but it makes sense. Okay, let's do it. Okay, normal distribution. So the upper, oh, that's something stupid. 34. What's my mu? Mu's 32. Whoops. Okay, I have got 0.0368. You know what? I am actually going to start testing. I'm going to start checking my answers as well because I get very lazy with this. As in, yeah, just let me, I'll do it. Question 5. Am I correct on that one? Oh, they do this. Oh, by the way, yeah, they do a different way. So they find the critical value and test against that. You can do it anyway. Yeah. Okay. So don't be surprised if you like look at the answers in the back. It's like, huh? This is just like another method of doing it. Okay. So yeah, and basically all we need to say, all I was checking was this was correct. It was correct. So we just kind of say, and first, then finally conclusion. With context, I'm not going to bother doing the entire context for you. Hopefully it's this bit. You can say that's less than 0.05. Does that make sense? So in critical region, therefore accept H1 or reject H0 and blah, blah, blah. You know, so at the 5% level thing, you say, okay, there is sufficient evidence to suggest that Kyle has increased. The mean number of hours Kyle spends studying each week has increased. Now, let's have a look at if we were to test at the 1% level, okay? Now, this virtually is exactly the same, except, you know, because the test distribution is still the same, so that's still the same. Our hypothesis thing, that's still the same, except now this is the 1% level. Does that make sense? So instead of this, we're not checking if 34 falls in. Well, let's have a look. Now we only care about the 1%. So we're checking, does 34 fall here or is it 34 fall here? But the area to fall inside it is smaller, if that makes sense. Now we know we know that when we look at 34 here, we know that that is 3.68% or the 0.0368. So where before, when we're looking at the 5% thing, we're like, well, if that's 5%, you know, if that's 3.6%, obviously it falls inside the 5%. However, when we're looking at the 1%, can you see 1% is going to be on this side? So that's the critical region cutoff thing. So here's the deal. At 5%, you would kind of say 0.0368 is less than 0.05. So in critical region, reject H0, yeah? And then you say sufficient evidence, blah, blah, blah. But at 1%, it's not. So you'd have to say 0.0368 is greater than 0.01. So not in critical region, you would accept H0. So that's an interesting thing to see, you know, because it's like, just to understand, you know how they say test at 5%, 1%. That's like saying, I want to, so at 5%, they're like, you need to show me that your kind of situation is in the bottom 5%. Bottom 5%. If you can't show me that, you cannot go around making these claims that what we said is different. But obviously on the flip side, they're like, you better be in the bottom 1%. Well, you know, can you see there's 5% gives you more of a chance to prove that H1 is wrong. Because you've given a chance to, as long as it's in the bottom 5%. If you lower the significance level, there's actually less of a chance of you having that crazy evidence. So your chances of rejecting H0 go down. Does that make sense? They go down. Yeah, so I think that's an interesting to show you that significance level doesn't actually change the working that much at all. It just, at this stage, just your little critical region smaller for a smaller significance level. So there's a less of a chance that you find it so crazy that you're gonna reject H1. Okay, fancy a two-tail? Let's do some two-tail stuff. And it's virtually the same. Oh, it's so similar. Okay, so let's have a look at a two-tail, and so I can explain to you as well what the hell is actually going on with it. Let's have a look at example 2 on page 302. Is that 302? Nah, it's not. That's the one I want. Okay, this is I like this one. I think this is really good. Okay, whoops. Okay, so let's have a little look at this one as well, yeah. So we're gonna go back to this. The distribution test. This is gonna be reasonably straightforward. So this one's actually worded in a weird way. So it goes: there's a machine which has a mean mu and a standard deviation 3. So that's kind of flipping useless in a way. Okay, so they're saying the background distribution is that, which is pretty crap to us because we need a value for that, right? So it goes out of a random sample distribution of 20. So that sample is all you need, because now you know you're going to be actually testing, that's the distribution you're going to be testing, yeah? So we haven't figured out our distribution test just yet, because, it's not like we can put, we're like mu 3 squared over 20. Yeah, we need that number, and, God, I'm talking everywhere. Okay, just keep that in mind right now. Okay, so you had a random sample of 20, which at least helps you with this bit of the distribution to test. And it goes the mean volume dispensed. So this is the actual value we're going to be testing. 30.9, okay? Don't confuse that because some people confuse that for, oh, we're looking for mu equals 30.9. No, we're not. That's what we're testing, okay? Now it goes, does the data provide at 1% significance level? So our significance level is 1%. That the machine dispensing the mean is different, not greater than or less than, different. So this is when you get your two-tail. So actually what this does to the significance level is it breaks it to 0.5%. I'm going to explain that in a second, but first I just want to do this. Did you notice this last bit? Different than 30 mils. So essentially that's what you're testing against. That's what you're saying, hey, is it basically equal to 30? Or is it, that should be 1. Or is it not equal to 30? So this is a really stupid roundabout way of just not trying to give you the mu, but then giving you the mu in a different way. Okay, so this is the thing we're going to be testing. We're testing like this distribution. So just like a dopey little kind of thing, which I like to do, twist and turn. But to be honest, you know what? You sort of do want those kind of things happening, because it's not rocket science, especially after you see a few of them. And any little weird twist, a good percentage of everyone taking the A level, they're now like, huh? This is different, and they just fall away. But yeah, I mean, it's good to see. Okay, so we're actually going to be testing that. It's going to be a 5% significant level, because what this is so you're testing 30 down the middle, and you're looking for, the crazy. We're not specific. We're just like, oh, is it in the crazy? We're saying, is it different than 30? So we're not saying, is it greater than 30 or lower than 30? We're like, if it's crazily too big or crazily too small, we're happy with that. So because we're doing like a total of 1% significance, these have to be 0.5%. Okay, which as a decimal will be 0.05. Okay, I see people every now and again make a mistake of that, because I think they're just so used to 2 zeros. Well, that's a 5%, so make sure you don't kind of get that confused. And yeah, okay, so let's okay, now actually assuming you understand that, oh god man, I'm all over this place. Let me explain the test which is happening here, right? If I can get my words kind of out. So you know how before, if we're testing the mu, if we're doing h1, the mu less than 30, that's pretty obvious. We're testing, does it fall into this region, right? We never had that issue with 1 tau. With 2 tau, so with the upper one, we'll be testing that side. Now, can you see, because our value to test is 30.9, we know 30.9 can't be here. I mean, it's the wrong side of 30. So we know that 30.9 has to land on this side. So we are going to be testing greater than 30.9. Because there's no point testing on the bottom side. We know it's not going to fall into that thing because 30 is down the middle. So that's the only difference with the 2 tau test. You just have to use your logic. If, by the way, our value to test here was 28.7, well, 28.7 will be on this side and we'll be testing probably less than 28.7. So a 2 tau test just involves a bit more brains, shall we say, okay? But there's no particular rocket science to this. And in a second I'll go, you know, okay, you know what? Some things are just better done as a question, pick it up. This is one of those, okay? So let's write our test distribution. So yeah, we'll write our background one. You know, we'll write our background one. So 33 squared. Remember, always look out for whether it's telling you standard deviation or variation. That's something which catches people out. And whenever it does, they feel so pissed off. They're like, I can't believe that of all things is what I've kind of like, you know, screwed this question up on. So make sure you look out for that. So you go, that's our test distribution. That's what's going to get our first mark. Now let's write our H0 and H1. So H0 is, you know, different than 30 mils. That's what we're testing. So mu is 30. H1, mu is different to 30. Okay, and let's set up our thing. So this is a 2 tau. Okay, so sig level, or sig value, or whatever you want to call it, we're looking for is 0.5%. And I would say each side. Because in reality, the only reason I'm saying that, by the way, is, I mean, the significance level is 1%, yeah? But obviously we're splitting into 0.5. Just to be clear, nah, that's not even important. Just write 0.5, you know. Only an idiot wouldn't give you a mark for that. Okay, 0.5%. And your test value is 30.9. So let's just have a look. I can look at this right now. We know 30 is down here. Our significance levels, you know, they're on both sides. And these are both 0.5%, which represents the value 0.05. This is 0.5%. This value represents 0.05 as well. And now all we decide, so 30.9 is obviously going to either land, it's either going to land here outside the critical region on the higher level, or it's going to actually land inside there. So, you know, to figure that out, we need to test probability of x greater than 30.9 and see what value we get, okay? So here we go for, you know, test it. So if I do probability x greater than 30.9, which gives you, bear with me, you do this as well, 30.9, 30. Okay, I have got 0.0899, which is 8.99%, which is huge. So here's what we basically found out. If I say that's 30, and I'm testing at 30.9, here you go. So I know that's 8.99%. Whoa, this is nowhere close to being, and remember, so this is nowhere close to being the 0.5% I need. So, you know, I can just finish this off by saying 0.0899 is greater than my 0.05. Remember, not 0.0, sorry, 0.005, not 0.05. That's the mistake a lot of people make. Not in critical region. Yeah. Except H naught, context and all that rubbish as well. Insufficient evidence or no evidence to suggest that the mean volume dispensed by the machine is different than 30 mils. And let me just make sure I haven't made anything haven't made a silly error or anything like that. Bear with me. Oh yeah, absolutely, yeah. I forgot this is it. I'm looking at the back of the book for the answers, and I forgot this is the actual example. Yeah, happy with that? Does that, hopefully that makes sense as well? And hopefully with that, that's probably going to be everything you need for the normal distribution hypothesis testing. We could do one more. Maybe we should do one more two-tailed test, just to feel nice and good with it. Yeah, let's do one more. If you feel, yep, that looks piss, that's good, yeah, move on, you know. There's no need to hang around. For the sake of hanging around, you can just skip this video until we get to the binomial. Make sure you go with that. But first, let me kind of find something. Oh, that's a good one. Okay, so let's look at question 2 in exercise 4.1. Yeah, just to show you some, you know, weird ways they might like to just kind of change up the question. Here you go. And I just kind of feel, you know, let's kind of do this as well. So, Bree plays cards with her friends, and the amount of money she wins each week is normally distributed with a mu of 24. So if I just write, I'm just going to make some notes so we know it's 24, and standard deviation of 2, so 2 squared. Okay. A friend joins the game and Bree thinks this will change the amount she wins. Okay, well, change the amount she wins, not higher or lower. So right now, H0, we know it's we're testing is mu 24. H1 is saying this is not 24. So we got a two-tailed test. Okay, in a random sample of 12 weeks. Okay, so your sample is your n equals 12. Well, that's given us what our sample mean distribution is, so it's 24 over 2 squared, or we could have just wrote that as 4, 12. Okay, so it's good to know. So we know that's a sample distribution, and so that's the distribution we're actually going to test. And we've found, and this is our observed value, found the sample mean was found to be 22.5. Sometimes, you know what they can do? They could actually mix it in with, so they could have said, oh, they played 12 played 12 weeks. Total one was £270. Okay, now that's just a cheeky way of not telling you what the actual sample mean was. So all you'd have to do for that is you'd have to do 270 over 12 to actually find out your answer, which will be 22.5. So that's like an alternate way you may have been asked if they want to really kind of like, you know, they want to kind of mix the hypothesis testing with a little bit of that, you know, that histogram sample, you know, the standard deviation means and all of that kind of stuff. That's one way they could do it. Another way they could have done it was, here's some of the, for 12 weeks of data, here's what they found. You know, if X is her winnings and stuff like that, yeah, they could have said that. That's another way they could have done it for you to understand. Hey, the total was 270, so you do 270 over 12 to get that as well. Little side thing there for you to keep in mind as well. And then you're testing at the 1%. But because this is a two-tail, you're actually testing at the 0.5%. Does that make sense? Bear with me. I'm just going to pause the video for a second. Okay, we're back. Yep, we're back. Okay. Go down. Okay, so let's just kind of just do this. Okay, so 1 is your distribution to test. Make sure you get that. Yeah, so you can write your initial thing anyway. 24, 4, or 2 squared, doesn't matter. Why did I write 12? 20. So it's 4 over 12. Good. 2. Let's write H1s and H0s. So we're saying mu equals 24. H1. Mu does not equal 24. Let's do our setup. Okay, so this is a two-tailed test, which means our significance level is 0.5%, you know, 0.005, and our test value is £22.50, 22.5, or you don't even need to write that 50, there you go, 22.5. Number 4, so just to kind of see this as well. Okay, here's your 24. We are now going to test. Oh no, of course not. Actually, no. Where's our test going to be? Well, can you see 22.5 has to be on this side? So what we're doing, by the way, is here's our critical levels. We've got it on both sides, and they have to be 0.5% each. So we're going to obviously be testing. We're going to try to find out the probability less than 22.5. And here's all we're trying to find out. Does 22.5 end up here? And the way you do that is, for example, if it ends up equaling 0.04, like 4%, you know that 0.05, so the 0.5% has to be, 22.5 is not in that kind of thing. Or if you get a value of like 0.01, which is like 0.1%, well, that would, oh, come on. Okay, then that would tell you it's here. Does that make sense? Because that would be like your 0.1% here. So now you know it's in the critical region. Let me just rub that out. Okay, actually, why would I rub that out? Yeah, okay, so let's test it. Find the less than 22.5 wouldn't be greater than. What's the point? Yeah, we know if it's going to be in the critical region, it's going to be in the lower side. It can't be in that one. It's not higher than 24. So let's do that test. Let's see what we get. Okay, here's what I got. I got 0.00469. Okay, so that, by the way, is 4.6. No, it's not 0.469%. So that is actually going to be in the critical region because here, okay, and it's just in the critical region. So I found out if that's 22.5, that's 0.469%. Okay. Which obviously the critical region is 0.5%. So this is actually, it's actually creeped just into the critical region. So, conclusion with context. So 0.00469 is less than 0.005. So in critical region, blah blah blah, context, sufficient evidence, there is evidence to suggest that the new friend, that the introduction of her new friend, that her new friend joining the game has changed the amount that Bree will win. That's it, okay? And you always give the context in terms of that. Even though it's kind of realistic, we think it's lowered, we don't say that because our alternative hypothesis was to believe it has changed, so we just say it's changed. Okay? So hopefully that's kind of sorted you out with normal distribution hypothesis testing. and in the second or on the next video, the binomial testing. Let's end this one. Ugh. Where is it?